Welcome back. Today we are learning more about logarithms, specifically simplifying them with some cool properties. To start with, some logs are super easy to simplify. For example, if we have log base 3 of 81, it's kind of like, okay, 3 to the what power gives you 81. So for these ones, it's kind of like the same base solving we did with exponentials. It's kind of like, okay, 81 is 3 to the 4th. So the only thing my unknown can be is 4. So I know that log base 81, I can get rid of that question mark, and I can say that that is confidently 4. Same thing with the next two. I would encourage you to pause the video and try them out on your own. All right, hopefully you've paused the video. We are going to go through the answers. So for this next one, what I want to do is I want to raise 5 to an unknown power, turn this into exponential form, and then I want to change the base of the right fraction such that it's the same base as the left base 5. So I know that 1 over 25 is the same thing as 5 to the negative second. Remember that negative exponent takes the reciprocal of any base. Alrighty, so in this case, I know that my question mark, my unknown, is -2, which means, hey, my answer, I can confidently say, is -2. For the last one here, we've got log base 7 of the square root of 7. What I'm going to do is I'm going to turn this into exponential form, and then from here, I have to kind of think because, the square root of 7 and 7 are not the same base. So what I'm going to do is I'm going to change the square root of 7 into 7 raised to the 1/2 power, because the 1/2 power, it is the same thing as the square root. So in this case, I can confidently say that my unknown, or what this log base 7 of the square root of 7 is equal to, is 1/2. So get rid of my question mark, and I can say confidently, hey, log base 7 of the square root of 7 is 1/2. But what about this situation? So we have log base 2 of an argument of -4. Okay, so my question mark is unknown. I don't know what this is equal to. So let's try it out. So I've got 2 raised to the question mark, which is equal to -4. So I'm thinking about something I could raise to the power of to get to -4. And I'm thinking like, oh man, I can't really raise 2 to the anything that would give me a negative number. Like no matter how big I make the question mark, the unknown, or how small I make the question mark, I will never get to a negative output value. So I think what we're trying to illustrate here is kind of a rule. And that rule is that the argument can never be negative of a logarithm. So as we're going through problems today, I want you to consider this, that we don't have any negative arguments, because really what this is undefined. Log base 2 of -4, guys, that is undefined. That is not something we define with any number or variable. It's something that, hey, we don't know what it is, so we're going to not define it. All right, next up, it's important to remember that every logarithm does have a decimal approximation. For example, log base 2 of 9. Now, I could put this into my calculator, in Desmos, and it would give me out some decimal, but I want to use my kind of numeracy skills to interpret the situation just with my brain, not a calculator. So I've got 2 to some power is equal to 9. So I'm thinking about that. It's kind of like 2 to the second gives me 4, and 2 to the third gives me 8, and 2 to the fourth gives me 16. So I kind of know that that unknown, that question mark, is going to be between 3 and 4. Similarly with log base 4 of 14, I don't know what this is, but I can consider that 4 to an unknown is 14, okay? So if 4 to the unknown is 14, well, let's think about this, because 4 to the first power is 4, 4 to the second power is 16, so I know my question mark, or my unknown, will be between 1 and 2. So it's going to be 1 point something, just like the previous one was 3 point something. Next up, we're going to talk about a couple different properties of logarithms, and these are really important to know. These are, skill bases that you kind of need to know in order to be successful with solving and graphing logarithms later. So we want to be really familiar with this. So take a second, read through each of these properties, and then what we're going to do is just go through a quick example of each one of these. First up, we're going to talk about the product property, which says that log base b of m times n is the same thing as log base b of m plus log base b of n. So my example I'm going to do log base 3 of 3 plus log base 3 of 9. And what I know is that if these bases are the same, both the base of 3, that means that I can keep the base and then multiply those arguments together. So 3 times 9 is 27. And then luckily for this one, I can actually simplify that because I know that log base 3 of 27 is 3. Next up, we're going to do the quotient, which is the quotient property, which is log base b of m divided by n. So if you're dividing your argument, that's the same thing as log base b of m minus log base b of n. So my example that I'm going to do is log base 10 of 20 minus log base 10 of 2, which is the same thing as log base 10 of that argument, 20 divided by 2. Or in this case, log base 10 of 10, which I'm kind of running out of room, but we know is 1. Next up, with the power property, what the power property says is if I have log base b of m raised to the p power, that's the same thing as p times log base b of m. So my example I'm going to do is 3 times the log base 4 of 4 equals, well, this is kind of like the same thing as log base 4 of 4 raised to the third power. And I know 4 to the third power is 64. And I also know that log base 4 of 64 is 3. So this is another example of the power property. And lastly here, what we're going to go through is just your general equality property that says if you have the same base and you have one logarithm on both sides of the equation, then the arguments are equal. So my example I'm going to give is log base 7 of x is equal to log base 7 of 10. So the only thing that x can be to make this statement true is 10. So what we're going to do next is we're going to use these properties to evaluate the following. And I want to think about this because in this case, I could probably simplify log base 4 of 2, in some way, but log base 4 of 32, I can't really, 4 to the unknown is 32. I don't know what that is. So what I'm going to do is I'm going to combine these logarithms using that product property. So I've got log base 4 of 32 times 2. I'm going to simplify, so log base 4 of 64. And then from here, I can kind of confidently say that, hey, log base 4 of 64 is 3, because 4 to the what power gives you 64? It's 3. So by using this property, I'm able to kind of quickly evaluate these two logarithms. Kind of similarly in the next problem, we've got log base 3 of 36 minus log base 3 of 4. So what I'm going to do is I'm going to use the quotient property by taking log base 3 and taking my arguments and dividing them. So I've got log base 3 of 36 over 4. Now 36 over 4, same thing as 9, right? And I know that log base 3 of 9 is just a normal little 2, all right? So lastly here, I'm going to use the power property. So I'm going to rewrite this 3 times log base 8 of 4 as log base 8 of 4 to the third power. Now let's simplify. So this is log base 8 of 64. And I do know that log base 8 of 64 is a normal old 2. So in all three cases, we use 3 different properties to help us simplify or evaluate these expressions.